IPC. These are the next set of Mrs. Hadaway's notes. This is the periodic table, and we're going to try and do the first page front and back. So, an element is a pure substance that has its own properties such as density, malleability, conductivity, and tensile strength. Density is mass per unit volume, how many atoms are packed into a certain space. Malleability means that you can hammer it into flat sheets like metals. Conductivity, does it conduct electricity or heat? And tensile strength, can you pull it into a wire? Or how strong is it when you pull it into a wire? So an atom then is the smallest component of an element that demonstrates the properties of that element. So an atom has all the properties of the element itself. The nucleus of any element's atoms contains the protons, we already talked about this, the protons and the neutrons, except for one particular element because it doesn't have any neutrons. Hint, it has a mass number of 1. You guys can figure that out and fill in that blank. If you don't have your periodic table out, take it out now. The atomic number identifies the element and how many protons it has. So if you remember, we've gone over this stuff before. So we talked about these things before. The number of protons is also the same as the number of electrons. In a neutral atom, those numbers are going to be the same. Remember, protons are positive, electrons are negative. The rows of the periodic table run, and I'm not quite sure what she meant to put in here. It could be they run left and right. They could be not quite sure what she wanted. I'm going to skip that and see if I can come back to it. The scientific name for the rows is, they're called periods. I don't think parade, I'm not for sure. So, and that's where the name periodic table comes from. It means that things occur in a pattern. Okay, when it's periodic, it means that it happens over and over and over again in a similar way. So, like the school, we call them period 1, period 2, period 3, and so on. Those things happen over and over again. So we have period 1, it's 45 minutes or 49 minutes, and then it stops, happens all over again. We say period 2. It stops after running about 40-something minutes and happens all over again. It's periodic. Your day is periodic. So periodic means that it happens again. So you see certain characteristics or properties as you go across, and then it starts back over again. And then it starts back over again as you go across. And what happens is you look and say that hydrogen is kind of a little freak that's in the wrong place, but if you look at all these, they have really similar properties. And then these guys in this group have really similar properties. Let's ignore these metals for just a second. All the guys in this group have really similar properties. So if you go over a certain amount, you're going to have these properties repeating again. Let's see. It means that things that occur in a pattern. Another example of something that's periodic is, let's say, I think she means a week here. The days of the week repeat over and over again. In the periodic table, we also see patterns occurring. So maybe it's a month, maybe? That's what she's talking about. So in a month, we have a Monday, and it goes through 6 more days, and you have a Monday again, and it goes through 6 more days, and you have a Monday again. So it's periodic. So you have that repeating, a regular repeating pattern. On the periodic table, the row or period an element is in tells you the number of energy levels it has. Draw it on your periodic table. Okay, so let me show you my periodic table. And the periodic table is kind of cool when you look at it. I'm going to expand this a little bit, or shrink it down, whatever you want to call it, so you can see the whole periodic table. It's a really cool periodic table here. So what she's talking about here is that if it's the first period, they have 1 energy level for the electrons to orbit in. If it's in the second period, there are 2 energy levels for the electrons to orbit in. So my little dot in the center is just the nucleus. If it's in the third period, it has 1, 2, 3 periods for the electrons to orbit in. Now, if I kind of cover up these transition metals like this, it's really kind of cool because you can see it better. Here, these guys have all 1 electron in their outside energy level. And as you go across, 2, 3, 4, 5, 6, 7, 8 electrons in the outside energy level. And then You go back and these guys have 1 electron in the outside energy level, 2, 3, 4, 5, 6, 7, 8. It goes over and over again. So we have something that's periodic. So what she's saying for the periods is this is what she wants you to write. Put a dot for your nucleus and then put a circle. There's 1 orbit or energy level for the electrons in that one. The second period, put a dot for the nucleus. There are 2 orbits. And notice it goes all the way up to 7. So there's 1 dot, 1, 2, 3, 4, 5, 6, 7 different energy levels for the electrons to orbit in. The groups or families are the columns that go up and down. And we'll see that elements that are in the same group or family tend to have similar properties and act alike. Why? It's all about the valence electrons. I know that you talked about valence electrons in 8th grade, so don't pretend you haven't heard that phrase before. Valence electrons. Those are the electrons in the outside orbit. So again, when I look at these, all these guys have 1 valence electron, 1 electron in the outside orbit, and they all act in a similar manner. That means they all are metals. They are all so reactive that you'll never find them pure in nature. And every single one of them will combine with chlorine in a 1-to-1 ratio. So we have NaCl, which you guys know that's salt. We can have LiCl, KCl, RbCl, CsCl, and FrCl. They all react in the exact same way with this chlorine over here. So they have similar properties. An atom's electrons fit into the atom's energy levels in a specific pattern. The first energy level or shell can hold up to 2 electrons. It's the smallest. The second energy level or shell can hold up to 8. The third can hold up to 18, but we are going to stick with 8. Because why? 8 is the magic number. 8's the magic number. So if you look on this, and this is the periodic table that I use with my chemistry students, and they have to draw this stuff too, right up here at the top. Magic number is 8. Don't know why. It's just that when an element has 8 valence electrons, it stops reacting. It's stable, but it will work. It will react with things to get to that magic number of 8. Atoms would always like to have 8 electrons in their outer shell, except for the first period or the first energy level, because it's so tiny it can only hold 2. It's stable with 2 electrons. You guys might remember you talked about the noble gases over here. They don't react at all. They're all stable already. And they're stable with, this one has 2 valence electrons because it's so tiny it can't even hold 8. All the others, even the big ones, are stable with only 8 electrons in their valence electron shell. So atoms would always like to have 8 electrons in their outer shell so they can be stable. Stable, non-reacting. Atoms will pair up or bond together so that the electrons in their outer energy level will add up to 8. The electrons in the outer energy level are called valence electrons. On the periodic table, the element's atomic number tells you how many electrons will tell you how many electrons the atoms have in their outer shells. Hang on. Okay, that's not right. The atom's group number, there we go, will tell you how many electrons the atoms have in their outer shells. In other words, the blank tells you the number of valence electrons. I don't know what she's calling this, but basically what she's talking about is, do you see these numbers right up here? 1, 2. I'm going to cover up this middle section. You guys can do this to your periodic table too. 1, here's 1, 2, and I'm going to cover up the 1, and here's a 3. Cover up the 1, here's 4. Cover up the 1, here's 5. Cover up the 1, here's 6. Cover up the 1, there's 7. And then cover up the 1, there's 8. Those are the group numbers, and they tell you the valence electrons. So everybody in this group has 1 valence electron. Everybody in this group has 2 valence electrons. Everyone in this group has 3. Again, you have to cover up the 1. Everybody in group 14, cover up the 1. They all have 4 valence electrons. So it's the group number. So in other words, the group number tells you the number of valence electrons. Once you get to group 13, you just cover up the 1, and the remaining number tells you the number of valence electrons. Atoms want so badly to have 8 valence electrons in their outer shell that they are attracted to other atoms that can make that happen. And the closer they are to having 8 valence electrons, the more reactive they are when they get to 8. So you say, well, wait, these guys only have 1 valence electron, like sodium only has 1 valence electron. But if I draw it out, here's my nucleus. I know the atomic number is 11, so that it's got 11 electrons. The first orbit can hold 2 electrons. The second orbit can hold 8. 1, 2, 3, 4, 5, 6, 7, 8. I've placed 10 electrons. I have 1 more orbit because it's in the 3rd period. I can move this over here. It's in the 3rd period. I have 1 more orbit, and that one's going to have 1 valence electron. Now look at this. If I got rid of that 1 valence electron, how many valence electrons would I have? 2, 4, 6, 8. Magic number. The closer they are to getting to 8, this guy's going to give up an electron. It's easier to get rid of 1 electron than it is to steal 7 to get up to 8. So the closer it is to 8, the more reactive it is. So all these guys that have 1 valence electron are crazy reactive. All these guys over here in group 17, cover up the 1, they've got 7 valence electrons. They are all crazy reactive here too, because they're so close to having the magic number 8. And let's do number 13 here on this page. For example, sodium has 1 valence electron. It will want to bond with elements that add that 1 valence electron to its 7 electrons. What are some examples? Look at all these guys right here. Cover up the 1, they all have 7 valence electrons. And let's stop here for the day and we'll pick up on number, the next number underneath the periodic table.